Okay, welcome back. Yeah, it's the continuous lecture of the previous introduction of the FEM course. So that let's keep continue. Yeah. This is a procedure of the FEM. Yeah. If you have some physics problem, so you need some mathematics model. Yeah. So that this is a basics of the engineering department. So that after you can define some mathematics model of the physics problem, so that it's done, so that you can apply some numerical analysis technique to solve this mathematical equation. So the FEM is one of the most promising methods. So that if you are, and also if you have a specific geometry, for example those kind of complex geometry, so that you can use a mesh techniques so that you can obtain the solution from individual specific element, so that result can be plotted in the complex geometry. So that this is a Stanford Bernie. So it is our work is strongly related to the CAE. However, those kind of geometric design is related to the computer-aided designing technique. So that many guys focus and demonstrated to make a good quality of those kind of designing tools. So if without those kind of CAD tool, we cannot achieve our well quality of the meshed structure. So that without good quality element, we cannot obtain the good result. However, if you have some problem in physical problem, and then you need some mathematics tools, so that, and then you also need some CAD design and then fine element, so that after the set up those kind of things, you can apply the FEM method to. And then next is a procedure, detailed procedure of the FEM problem. So if you have a physics problem, you prepare the mathematical model, we can obtain the numerical solution. And then if the answer is make reasonable, if the solution is reasonable, yes, happy. However, if not, so that, and then we need some refined analysis technique. So that first thing is improve mathematical model. Very important. However, we cannot changing the mathematics or so mathematics is good. It is because that exact solution is well follow the real physics phenomenon. At the cases we don't need to improve the mathematical equation. At the cases, we need some design improvement or structural optimization. That means that we did designing, CAD designing, so that, or changing the physical problem, that we need those kind of procedure. So this is a more detailed example related to the solid mechanics. If you have some cantilever beam of the solid structure, those kind of things, this is a continuous model. You can designing this continuous model using the CAD software, and then using the some in the FEM software suggests the to discretize, generating the mesh techniques, so that after obtained those kind of well refined geometry meshing element, so that applying the same boundary condition, for example the uniform loading or fixed boundary condition, so that, and then you can apply your physics into the FEM technique. So that in the previous slide means that pre-processing, and then analyze means that applying numerical technique. So that first we need defining the exact element and node. It is because we have various types of the element and node, and then among the number of the element, we should define the local stiffness matrices in the single element, and then we are going, next step is assembling this single local stiffness matrix into the global stiffness matrices, so that, and then finally we can solve it. And after the obtained some solution, we need some post-processing to plot the result in the graphically, so that this is a procedure. So yeah, let's check the pre-post processing means that is from the continuous model we should designing the fine discretized element model. Next in the analysis step we should define some single element first, so that how to it's the theory of the FEM method, so that we are going to learn about how to defining the physics equation in the single element, so that the result will be described by some matrix form. So that after obtaining some local stiffness matrices, this equation can be always used the integration. It is because that this is a weak form equation, so that it is because the whole governing PD equation shows a good result in whole domain. However, our numerical result always shows some error compared to the exact solution, so that after using the integration technique, so maybe so that we can divide it by the continuous part to the very small piece of the part, so that after the obtaining the local stiffness matrix in the whole element, so the next step is assembling step. So that assembled means that it's not a simple summation of the matrices, so that we put some the local stiffness matrix into the proper position of the global stiffness matrices, so that this is there are many ways to the assembled techniques in the FEM method. So next lecture we are going to learn about the details. So that after the finishing the assembled, so that we have finally obtained the global stiffness equation, so that our unknown is a u, maybe displacement, k is a stiffness matrix, or for example Young's modulus, so that if you f is a pulse, is a known variable, so that this is a u is an unknown variable. So taking inversion of the k and then multiply with f, so that finally we obtain some unknown variable solution. This is a procedure of the FEM method. After obtain the solution, so that this is a vector form, so that we should put some of this result a proper position. This is a post-processing procedure. So maybe the many commercial software suggest the pre-post processing and post processing. Also, they also have some analyzed solver, so that so we are going to learn about the analyzed solver details, so that I don't think that it's easy to make pre-post processing and post processing software by MATLAB. So however, if we are going to use a very simple geometry, so that it's not a big deal to do the pre-post processing and post processing. So, and then we are going to demonstrate it more in the analyze step for the if we are going to make some FEM code by MATLAB. So this is the end of the procedure of the FEM. So the next is application of the FEM. FEM techniques is well used in the variety field. So first field is designing some airplane or car. So it is because the aircraft always experience large stress due to the air resistance. So that to obtain those kind of interaction between the air and solid structure, we should solve the Navier-Stokes equation and deformed solid geometry equation. So that to designing those kind of craft, we using the FEM method. So also the it's very similar equation. So that in the already shown those kind of field in the Midas when we introduced the Midas company, so that FEM technique also used in the construction. For example, build bridge construction, so that before we start the construction of the bridge, we must check the mechanical stability of the bridge designing. So the FEM is well broadly used in the construction industrial field. So we can test the several environments, for example, earthquake or large crushing on the bridge, or some waiting of the car during the driving through the bridge. So that the cases we can virtually test the whole situation, so that we can test the safety of the bridge before we construction of the bridge. So the next is car designing, so that which are already shown the previous video slide. So that this is so we can check the deformation of solid body structure and stress sample pile using those kind of FEM method. And this also we can also apply to the heat transfer or electrical problem, so that we can also designing the engine system. So due to the large temperature increase, the engine solid structure will be deformed, so that we can couple the thermal stress problem with the heat transfer mode problem. Also, we can also designing the microchip due to the electrical current flow, so that the heat will be generated. This chip will deformed due to the thermal stress, or we can solve the current flow itself by FEM designing. So although the electrical department and chemical department and other major other researchers which are major in different subjects also want designing something, so FEM method we can help to the other guys. So that I think the FEM is a strong point in those kind of things. We can use many variety of the shapes of the geometry. So, and also these days the bioengineering is one of the main field of the FEM method, so that we can designing our heart or part of the body using the cat pile. So that, and then if you know that the exact material property of the bodies or bone structure, so that you can simulate it by FEM software simulation. So these days, so bioengineering, it is because that designing robot also main field of the FEM method. So I think that you can, if you want to do simulated of the any problem, you can apply the FEM technique into your interesting. So that my main research focus on the battery designing, so that actually material design or battery design itself. So that these days I also use the FEM method into my research for my research. So I'm using the designing of the material or characterize or analyze the deformation of the high energy materials. So that I also check the behavior, electrochemical behavior of the battery system by mimic the real battery geometry. So that we can, using the CAD software, we can designing the real battery system, and then we can apply the mathematics equation into the battery phenomena to describe the battery phenomena, so that we can obtain some solution, so that we can compare it to the real battery and my simulated result, and then finally we can obtain the finally we can analyze the behavior of electrochemical. So this is the end of today's lecture. So the next week I'm going to start the theory of the very simple cases of the FEM. So if you have any question, please ask to me freely anything and you want. So then maybe please watch the video about how to install the computer software and how to use the console in your desktop. So bye bye.